Hello and welcome to the SpaceNet video on adding an RF node to the network. So the way SpaceNet works is that in order to convert from a fiber network to an RF network, you need to have an interface. So what SpaceNet has us do is that we need to place a fiber node, and then we need to insert in an RF node module inside that fiber node. So first thing we're going to do is if you click on your Add tab up here, and under the Add Fiber area, click on the node RX. Alright, so we are in Western Washington, so I'm going to choose an NC4000 EG node. Now, you have to find out what node you're going to be placing, and you can find that out by either through job tracking or you can ask the OPE. So, I'm just going to choose this one. The Z's mean that these were imported in from low data. So, okay, so I'm going to select that one, and the designation is going to be your new node name. I'm just going to put right there. Alternate name. I'm just going to put in fiber just so I know this is the fiber node. Okay, construction status. Either this is an as-built design. I'll do designed. The plan owner is going to be Comcast. Okay. All right, so that general tab is now filled out. Now I'm going to click on the site attributes. Up here for the street address, if you know the street address, that's great. Go and fill it in. One cool little trick that this has built in is that if you click on this little three dot button here, you can then choose a building, aka choose an address. An address is both a building and an address. So I'm just gonna click on, see, 1980 here. I'm gonna click on 1981. So there we go, and I'm gonna hit done. And what that's gonna do is that's gonna import in all that data from that address. And that's all you need to fill out for here. And then under construction status again, we'll do designed. And then custom attributes, you don't need to fill anything out. So, all right, we are now ready to place our fiber module. So, let's just say for this exercise, we're going to replace this mini with a new node. So I'm just going to place it offset somewhere on the map so that we can work with it. So I'm just going to click here. So, like I said before, right now we're creating the fiber node, which then we will insert in an RF node inside. Okay, so you notice that it's white. The reason why it's white is because we have a construction status. If I click on it and then click on edit, we have a construction status of design. Now, if you want it to show red, then you have to click none, and that'll bring it back to red. So, but we're going to do design for this exercise. Okay, so now we have a fiber node. Now we need to add our RF node. There's two ways to do that. One, you can click on the Add tab up here, go to the fiber, and then click on Node. Or if you're still on the SpaceNet tab here, after you selected it, you can just pull down your Add pull down, and there's RF node right there. Okay. All right, so this should match the same fiber node that you have. So in our case, it is the HLN 3144, or sorry, the NC 4000 EG, not the SG. Okay, equipment name is going to be the same node name, so new node name, whatever that is. And then this one I'm going to do RF node, just so I know that this is the RF node. Okay, construction status is designed. Under the RF tab, we're going to select RF network device. Under the construction type, in this case, it's overhead. I believe the device we don't fill out, and the custom address we do not fill out. All right, now that we're ready, we just click on Add, and it's going to give you this little window saying we are about to add RF node into the existing fiber module. We'll just go ahead and hit yes. Okay, and that's it. Hit close over here. And now if you notice, our node now has 4 output ports for our RF design. So now that we've inserted in the RF portion into the fiber node, now we have to basically create an interface from our fiber to our ports. So what we're going to do in this case is that we're going to assume that we have one fiber for return and one fiber for forward. Now, obviously, there's going to be different configurations. You can have up to 4 fibers for return, 4 fibers for forward. But in this exercise, we're assuming just one fiber for return and one fiber for forward. Also, there will be a fiber cable connected to this node as well. But in this case, we don't have that, but normally you should have that data. All right, so what we're going to do is we're going to go into the details. So we have our node selected. Click on details. Okay, so in here we have two pieces of equipment in this casing. One is our fiber node, and then the other one is our RF node. And the way you can tell between the fiber node and RF nodes is the fiber node will have a port bank right here, and then the RF node will just have your ports A, B, C, and D. And that's how you can tell the difference between the two. So what we're going to do is, on the port bank, click on the new node name, or the name of the node, go over to Edit, and then click on Edit again. So what this is going to do, now we're going to create a port bank modification interface that will connect our fiber to our RF ports. Okay, so under Interface, click the button and select from current site. Okay, then click New, and then there's the interface owner. Give it a name. So call it New Interface. And you want to check the instant based mapping, because what that will do is that'll allow you to select individual fibers to individual fiber or RF ports. If you click on the default, it won't allow you to have that option to do that. So click on instant based, hit add. Okay. Now, if you are muxing the node, if the node is being muxed or if it's being fed via DWDM channels, then on the carrier type, what you would select from there, you would select wavelengths, select, and then there you go. So now it has the option to not only select the individual fiber, but also go down into the channel level, which we'll go and do that for this instance here. So hit apply, and then hit close. So now we have our port bank created. Now we have to go to the RF node and include that interface down there as well. So under your RF node, go ahead and click just have that highlighted, go to Edit, Edit, and this window comes up under RF. If you notice now down here, we have a carrier type and an interface. So since we selected wavelengths for the carrier type on the fiber node, we'll go and do the same thing for the RF node. So select wavelengths. On the interface, you should see the new interface that you created. So click the button, hit the new interface, hit apply. Okay, so now the fiber node is associated to the RF node is now associated to the fiber node, and now we can actually associate the fibers to the RF ports. So go back up to new node name, hit edit, and now we have this new window called port mappings. So go ahead and click on that. It says, hey, there's no mapping for this interface. Do you want to create one? Yes, we do. Okay, so now we're at the add port mappings for the new interface and new node name that we've created. If you notice on the left, we have our fiber node. I like to go from left to right. So fiber node's on the left. The RF node is on the right here. And then the carrier name is wavelength. So now we have the option to go down into the individual channels of your wavelengths if this actually was a muxed node. But in this case, we're not. So we're going to have all channels selected. Under the ports here, you notice that this is the fiber node because you have your forward and your return fibers. And over here, you have your ports A, B, C, and D. So that's how you'll only have your fiber and RF. So what we're going to do is, since we only have one fiber for return and one fiber for forward, we're going to associate the forward one fiber to all 4 ports of the node. So port A, forward 1. The direction here we got to change. It's not bidirectional. This is a forward signal. Okay. So we have forward 1 going to port A, forward signal. We're going to click add. So here we go. All port mappings. Now this window comes up. So far we've successfully associated fiber 1 to port A on the RF node. Now we're going to go ahead and hit new and continue that process. So hit new. That stays the same. All you got to do is change this to B, hit add. Fiber 1 now is at port B. New. Change this to C. Fiber 1 to C. New. And then fiber 1 to D. Okay, so now fiber 1 is now associated to all forward ports of A, B, C, and D. Okay, on the new one, on this 5th one here, now we're going to associate the return fibers. So on the ports over here on the node, on the fiber node, we're going to click return 1. And then on the direction, we're going to change it from a forward signal to a return signal here. And then we're going to go back up to port A, on the node, and we'll begin again. Okay, new, change A to B, so it's a return to B, add, new, C, add, and our last one, return D, add. Now we have successfully associated all 2 fibers to all 4 ports, both with a forward and a return direction. And if you made a mistake on one of these and say you forgot to do the direction piece, it's simple. You just click on the one that you need to edit, click on edit, and you can change anything you need to right here. Alright, so now we can close out of here. We can close out of here. And now we can select our newly created RF node, even though technically what we're selecting here is the fiber node. But we can click on one of these ports here. I'm going to click on port A, and I'm just going to do a test of our signal. I'm going to add a cable, an RF cable here. Let's go ahead and do 625 aerial new here. This is a tapped coaxial cable, and it is in the air, so I'm going to click add. I'm just going to associate the 183 and say the 205. Do a little drafting here. Obviously, this is not to Comcast offset standards, but this is just for this test. I'm going to go over here. I'm going to right click, and I'm just going to insert a passive device here, a line terminator. Alright, we do want to place an end-of-line bubble here, so I'm going to click there. And there you go. You now have successfully added an RF node to SpatialNet.